So I thought I'd just keep going. So I'm gonna do 1.2 as well right now. I'll probably do the other ones like later or tomorrow. I'll probably do like 5 in a row tomorrow or something. But here's 1.2 types of data. I think this one's important. Well, they're all important. So I'm sharing the screen. Um, I have the questions 1.2. Where is this? I did 1.1. I wrote a bunch of stuff in here. You can follow along with the other video. Here is 1.2. Do problems 1 through 4, 6 through 30 every third. I'll do as many as I want. So we go to eText. How do I get here? Sorry, if you missed the first video, I need some more space. All right, so we go to my math lab and we click on this, brings us here, and I click on this, and then I get here, and I'm going to teach about data. What is data? Pieces of numbers that give us information, nothing too crazy. We've got the first two ideas of differences are discrete and continuous. So that's how do I think about it? Continuous, it's got every little numbers in the middle. You can think about heights, you know, you could be 5'7", you could be 6'1", or you can be everything in between. Discrete data, that's where they're countable. So it could be like, so this is a good example of continuous and discrete. I don't know how many how many chocolate chips are on a cookie? I have 5 chocolate chips on that cookie. It is countable. Um, that's a really good way to think about it. We're talking quantitative. What does that mean? So we got quantitative versus qualitative. Notice that quantitative has an N here. That N I think about for numbers. How much snow fell? How many inches of snow fell? There was a time when quantitative was like the most important. They would never do qualitative. So qualitative has this LIT in it, and that's like, you can think about it as like interviews. Uh, you could think about it as like, how do you like this course? Oops, I don't know how that circle got there. This course, and the answers could just be yes or no, or a little bit or a lot. But that's the difference between qualitative and quantitative. Let's see what else we got. Cautious. Okay. Hmm. This is a good one. So the concept of countable data will play a key role in preceding definitions, but is not a particularly easy concept to understand. Continuous data can be measured, but not counted. Oh, that's very interesting. So we can measure this, and the other one we can't. If a particular value from a continuous data, there is no next data value. See example 3. I like it. So I'd read this discrete versus finite. Discrete versus infinite. So finite is something that stops. Infinite is something that goes on and on forever. But this is interesting. Number of students in each class. Tossing a coin forever. Interesting. We can think about dice. Dice is usually the one that's used most for this stuff. So if we throw a dice infinitely, what is the probability that we will roll if we roll 2 dice, let's roll 2 dice. Here's a good example. And I always like break up the dice so I can see all the parts. This is my dice. There's 6 of them. And if we were to toss it an infinite number of times, what is the chances of me, oops, rolling I don't know, we'll say a 7 or and 11. So or in math is always adding. I know that's kind of crazy, but or is always adding when it's probability. If it's at 7 and 11, it's harder to do. If I have to roll a 7 and then an 11, way harder to do. So that'd be multiplying. Why is it harder for multiplying? Because we're talking fractions for probabilities, and this is bigger. Adding will be bigger. I'll show you the difference between these two. So a 7 and 11 and then a 7 in this. So how many ways can I make a 7? Well, I can go a 1 and a 6. I can go backwards 6 and 1. I can go 2 and 5. Go 5 and 2. I can go 3 and 4. I can go 4 and 3. So that is 1, 2, 3, 4, 5, 6. And how many total do we have? 36. 36 possible options. And now for the 11, it's going to be, this can be 6 and 5. And, oops, sorry about that. And 5 and 6. Oh man, sorry that's so ugly. Here, let me just stretch this out. 6 and 5 and 5 and 6. That's only two ways. I can't go 7 and 4 because there's no 7 on here. So this is just two ways. So 6 out of 36 and 2 out of 36, that is 8 out of 36. You always add the tops, you keep the bottoms the same. I would probably simplify this, which would be a 4. I'm dividing by 2. 4 out of 18 for a 2 out of 9 chance to roll a 7 or an 11. If I wanted this as a decimal, 2 goes on top, the 9 goes outside. 9 goes into 20 twice. 9 goes into 20 twice. So it's just 0.22 or 22%. All right, now if it's 7 and then an 11. So that means the first one, I still have this 8 out of 36 shot, but it's much harder to do it, right? So then I have to multiply this by 2 out of 36. Well, 8 times 2 is easy. That's just 16. But 36 times 36, ooh. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. 0. 3 times 6 is 18, carry the 1. 3 times 3 is 9, plus 1 is 10. 6, 9, 2, 1. 16 out of 1,296 shots. This is hard. So if it ever gets too confusing, you can just pull up a calculator. That's always a nice little cheat move if you need one. Just don't use a graphing calculator. 16 divided by 1,296. What is this? 0.01. Very small. So we times it by 100. It is 1%. Or 1.23%, however you want to slice it. That's why it's much harder to roll a 7 and then an 11 versus a 7 or an 11. This is what's called theoretical probability. We're not counting the experiment. So if we were to roll 1,000 times, these are the chances: 22%, 7 or 11, 1.23% to roll a 7, and then magically to roll an 11. 1 out of every 100 times that'll happen. Don't gamble. All right, we'll keep going through it. Okay, grammar, fewer versus less. When describing smaller amounts, use fewer for discrete amounts and less for continuous amounts. Oh, okay. This stuff gets confused a ton. We got ratio, interval, ordinal, and nominal. Nominal, I always just think about as names. Nominal, to me, sounds like names. It's a good way to think about it. That's why it's like categories. Like they said, eye color. Ordinal, think order. Ordinal, we want to think, oops, sorry about that. Ordinal, we want to think order. And that's arranged in order. We're ranking something first, second, and third. Interval. Okay, this is where it gets a little confusing. Okay, so interval can be a little confusing at times. There's no real zero here. That's the only difference. We're talking about, um, we're not starting at zero. We're starting at 36 degrees. I still don't even think this is great, but it's basically when you don't have a zero to start measuring from, that's when it's an interval because it's like a set. So it's basically, you can think about this as numerical, no zero, no true zero. And then finally, we have what's called ratio. You know what ratio ends in? An O. So it's numerical with a zero. Hope that was useful. This stuff gets confusing. So that's why I always try to remember nominal name, ordinal order, interval, numbers, just no zero, and ratio, numbers with a zero. Okay, you can look at all the examples. Is this the end? Okay, okay. Big data and missing data, too much data. Okay. Big data, too complex. It's really hard for us to use software tools when we're talking about like GDP, like giant numbers. And then we can use programs to kind of help us with that. Okay, what is this? Do they have Googleplex? They don't have Googleplex. Yottlebytes, 10 to the 24th. These are exponents. These are numbers that fly in the sky. So if I have, notice that it's always 10 first. Why is it 10? It's our base. 10. 10 fingers, that's how we count. Our bases are always 10. But basically, if you want something like this, like a Googleplex, you just go even bigger. That's 10 with 100 zeros at the end of it. Kind of crazy. But this is all just building off of scientific notation. So scientific notation, let's say we have 3.67 times 10 to the fifth, or point oh, sorry, or 1.23 times 10 to the negative third. This means we got a big number because it's a positive. Well, if it's negative, that means it's going to be a really small number. We use this all the time because it's hard for us to do math or write stuff when it's that much stuff there. That's why exponent's really helpful. So 10 to the negative third, you take the 1.23, we just move it 1, 2, 3 spaces to the left. We just drop in the zeros. So 0.00123. This one's going to get bigger, so I usually just write a new one. So here we have 3.67, 1, 2, 3, 4, 5. And that's where the decimal goes. So in each one of these, you can even count them 1, 2, 3, 4, 5. So we have this 1, 2, and then there's a 0, a 0, and a 0. So it's 3, 6, 7, 1, 2, 3, comma, 367,000. That's how they work. You can go backwards and forwards if you want. All right, let's see if we have missing data. Okay, so the dashes means we don't have anything for that. It's going to make it harder for us to run it. A data value is missing, not at random, if there's a reason for it. Okay, so what can you do? If you're missing data, there's a lot of things we can do. We can put the average in so it doesn't mess with us. That's like putting stuff in, substituting a value for it. We usually use the mean for this or the mode. The mean's the average, the mode is the most. Or we can just throw out the case. If they're missing too much data, we can throw out the case. We can randomly select the number, or we can take the mean to put it in because that won't really change the rest of the data. Oh, okay. We get to try a couple. So let's try a couple. We got 1 through 4, 6 through 30, and that's every third. All right, my lapse is going to die soon, so let's see how many we can do before it dies. 1 through 4, 6 through 30. I'm pretty sure that's what it is. Yes, and this is every third after the 1 through 4. Okay, so what do we got? Parameters, it's a critics security survey of 1,001 adults. It was found that 69% of those surveys believe that their personal information was stolen is inevitable. Identify the population. Oh, statistic or parameter. I don't think we went over this. So statistic is for a sample, a parameter is for like everybody. This is a good thing to start with. So a statistic is for just who we got, is the small sample. And the parameter is if it is for the entire population. So can we make a judgment on the entire population? That's the difference between these two terms. So the population in this case is all adults. Our sample is the 1,001 adults. Oh, sorry, it's US. All adults or American adults are all adults in the US. So it's 1,001 American adults. And they're saying it was found that 69% of those surveyed. So this is sorry about that. This is a survey. So this is statistics. 69% is the stat. That is the stat. Okay. Okay, quantitative is numbers, categorical are categories names. So let's knock out two. The platelet count of data set 1 in Appendix B. Platelet count, numbers. So that's quantitative. All right, let's look at B. Cigarette brands. Oh, that's easy. So the brands got to be categorical because they are Marlboro, different brands. See the colors of M&Ms, categorical. And D, the weights. We got to measure it, quantity. All right, let's look at 3. Which of the following describes the discrete data set? Discrete. So discrete and continuous. Discrete means they have to stop, right? It's just an amount of something. Continuous is like, so the heights of all the basketball players, I'm going, oh, this is where it gets confusing. Maybe we can look this one up. They say exact heights, I still want to go continuous. Just me. The numbers of people surveyed in each Gallup polls preceding the next, and the exact times, because they're using this word exact. Pretty sure they mean discrete. But we can look it up. I'm gonna hit Control F right now. You see how that just came up? I'm gonna look up the word exact and get right to here. Oh, I'm just in this one, so it'd have to come out. I'm pretty sure that for 3, the exacts are discrete and the number of people is the continue. No, I think this is gonna be continuous, and then the number of people, those are separate people. So I'm gonna call this one. If I'm wrong on this one, look it up, but this is what I'm thinking. Just makes more sense to me. All right, let's look at 4. In a survey of 36,000 adults, 30.7% they regulars eat cigarettes based on the national data. Okay, do we have everybody? No. So this is the population for 4. The population's gotta be what? The all adults. And it's in our nation, National Center for Health, so all American adults. Sample is the 36,000 American adults surveyed. All right. This 3.7% is of them, so the 3.7%, that's got to be a what? That's a statistic. Now, what level of measurement is this? We do have a true zero. We do have a true zero, but it's 3.7% said that they regularly use that. So nominal, ordinal, interval, or ratio. I kind of want to go with ratio for this one. I could be wrong, but I'm thinking it's ratio. You got a better reason, let me know. And is this discrete or continuous? Well, I'm just going to look back up at the discrete and continuous. Just for my own sanity. And I'm going to look up the word by hitting Control F and looking up exactly where they use this word exact. Concept of countable data plays a role in definitions, but it's not a particular easy concept to understand. Continuous data can be measured, but not counted. So it is the heights. We did this right. This is going to be counted. So ours is discrete data. Nice. I would read it up too if I made some mistakes, but that's what I'm thinking. And let's do a couple more before I end this one. So 6 through 30 every third. So let's do a couple of these. I'm going to jump to 6. We'll see how it goes. And again, if I made a mistake, feel free to let me know. All right, let's start with 6, and we'll do a couple. Identify if it's a statistic or parameter. According to the Federal Highway Administration, there are 212 million licensed drivers. Okay, this is obviously a parameter. They're talking about every possible person. And let's do 9. In the same study cited in the preceding study of newborn babies, okay, 51% of the babies were girls. This is a statistic. It's not every single baby. And 12. According to these, this is everybody. That's a parameter. And we can do one more. These aren't too bad. The clerk of the U.S. records the number of representatives at each. It's counting. It's not measuring, it's counting. Guess what? This is discrete. And I will let you guys have out the rest. Yeah, this will be good for everybody to try. Give it your best shot. You can give a reason. I guess I could do 2 more, but I think this is probably a good place to stop. But as I said, I'll do most of the homeworks for you. We'll get there. The insurance highway collects data, the number of motor vehicle fatalities caused by driving while testing. To me, this is not measuring, this is counting. So 18 is also discrete. But give me a reason. You should be providing reasons for these, and I'll do 21. In order to better plan for incoming freshman class, Ecology asked newly permitted to identify their likely major. Okay, this is not an order. No, it's not an order. It's not a set of numbers without a zero. It's not a set of numbers with a zero. This is nominal. These are names. So 21 is nominal. And a perfect answer for me would be look at the names. Okay. I'm going to stop this here. Good luck with this one. Reach out. Let me know how I can help. Hopefully these are useful. Tell me how they can be better. Take care.